welcome guys. Today in this video I want to show you the greatness of Euler's formula. So actually Euler's formula gives the relationship between the complex numbers and the real numbers. And if you see that if we have something like e raised to x, then it can be approximated by 1 plus x squared by 2 factorial plus x cubed by 3 factorial, like this. And this x value, it works for all value of x, and this is the Taylor series expansion of the e raised to x. And we also have cosine x, so this can be expanded by using the Maclaurin series or Taylor series, and we have 1 minus x to the 2 factorial plus x4 by 4 factorial minus s6 by 6 factorial, like that. And we also have sin x, which is x minus x cubed by 3 factorial plus x5 by 5 factorial minus x7 by 7 factorial, etc. And the beauty of Euler's formula is that if you raise anything with respect to like ix, then this is equals to cosine x plus I sin x, okay? And it is very profound result. If we look very carefully, this cosine and sine, they are trigonometric functions, and you know that the sine and cosine have sinusoidal property, like this, and this is 0, pi by 2, pi, 3 pi by 2, 2 pi, like that. And a cosine will have like this, so it will have both the sinusoidal form. But if you see very carefully, if we raise just e raised to x, then this one we have function like this, exponential function y equals to e raised to x. So can you see this? The e raised to x gives this function, and our sine and cosine independently they give sinusoidal wave. But what happens is that if you raise in the exponent with the imaginary number I, which I is negative 1 square root, then you just get is the phasors, which means your function now just have this r vector, and then it just moves in a circle with the angle theta. So how beautiful is that? When you raise the x, you just get the exponential function, and sine and cosine you get this way. But if you raise I is to x, e raised to ix, imaginary number, then it is equal to this, and then it just moves in a complete circle. So this is the greatness of Euler's formula. So this represents the phasors, and it will give the relationship between the rotating bodies, like the relationship of the velocities, like in the Hooke's joint, like in the current and the voltage in the electrical circuits and all. So this is how it is very effective in engineering also. It's very useful mathematics tool, and the beautiful formula is that if you raise e raised to I pi, here x equal to pi, then we get that cosine pi. Cosine pi is what? It is negative 1 plus I, then sine pi, sine of n pi is 0, so you will get 0. So we have cosine I pi is minus 1, and if you just move here, then you will get e raised to I pi plus 1 equals to 0. And this is also one of the most beautiful equations in mathematics, where you see the transcendental number, which is pi, then imaginary number, then the constant, an exponential function, and algebraic number, okay? So this is very effective, and this is the brief of greatness of Euler's formula. Thank you.